My name is Marta, and I will explain what a random variable is, how to write down the probability distribution, probability function, and introduce the basic vocabulary that we'll need in this chapter, discrete random variables. Let's start with the vocabulary. An experiment. An experiment is the action. What is happening in the question, in the exercise, or in real life. For example, tossing a coin, rolling a die, picking a ball out of a box, tossing 3 coins, rolling 7 dice. These are all examples of experiments. In my example, I have 3 fair coins are tossed. So this is my experiment, tossing 3 fair coins. Next, sample space. Sample space is the set of all possible outcomes, all possible results. So if I toss 3 fair coins, one of the possible outcomes, result, is heads, 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 3 heads. The other one, 3 tails, 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 tails. Or 1 time heads and then 2 tails. Could be first tails and then heads and then tails, or tails, tails, heads. These are all the outcomes with 1 time heads, 2 times tails, or maybe 2 heads and 1 time tails in all the possible configurations. This is the sample space, so all possible outcomes. The next thing is the random variable. In this experiment, the number of heads, x, is counted. So x is our random variable, and this is the set of possible values. The number of heads, could be 0, so 3 tails. Could be 1, here we have 1 time heads. Could be 2, here. Or could be 3, here. So here we have 0 heads, 2 heads, 1 times heads, and 3 heads. These are all the possible values of the random variable. If I write down the probabilities now, the probability that I got 0 heads, that would mean that the random variable is equal to 0. That means the probability that the random variable is 0, so the value of the random variable is 0, so I have 0 heads. Well, let's see. In total, in this sample space, in this experiment, I have 8 possible outcomes, and only 1 is 3 tails, so 0 heads. So the probability of getting 0 heads is 1/8. And now I can find the probability of x being equal to 1. So of the result being 1 time heads. And that's here. I have 3 out of 8 results. That's the probability of the random variable being equal to 1. Then probability that it is 2 is the same here. So it's also 3 out of 8, and the probability of 3 heads is 1 out of 8. Only 1 result out of 8 results is 3 heads. If I present all of these probabilities in a table, it will be the probability distribution. So let's create a table. This table will be called probability distribution. In here, we will observe how the probability is distributed. So what's the probability that the random variable is 0, 1, 2, and 3? At the top, I will just list the possible values of the random variable, 0, 1, 2, and 3. And the values are denoted by a lowercase x. And then in the bottom one, I will just list the probability that the random variable is equal to x. So that the random variable, the value of the random variable is equal to this lowercase x, so 0, 1, 2, and 3. So I will just copy those numbers. The probability that x is 0 is 1 over 8, 1 is 3 over 8, 2, 3 over 8, and 3, 1 over 8. This is the probability distribution. Now let's try to prepare a probability function. The probability function will be a similar thing, just the format will be different. So now I would like to see how the probability, what are the values of the probabilities. Instead of creating a table, I will create a function notation. That's the only difference. So the probability that the random variable is equal to is, well, I have two values of 1/8. So I can just write 1/8 is for x equal to 0, here 0 or 3. And then the other value is 3/8, so I don't have to list it. I can just include it one time in one row. The probability 3/8 is for 1 and 2. So for x equal to 1 and for x equal to 2, the probability is 3/8. And that's the probability function. Just to sum up, in my example, the experiment was to toss 3 fair coins. The sample space is here. That was the set of all possible outcomes, results. The random variable is the set of values from the experiment. In this case, it was 0, 1, 2, 3, because the random variable was the number of heads